What is going on, guys? Welcome back. In this video today we're going to talk about ensemble learning, how it works, why it works, and how to implement it yourself. So let us get right into it. Alright, so we're going to talk about ensemble learning in this video today. And the basic idea behind ensemble learning is to combine multiple machine learning models into one model. So for example, in the case of a classification task, like classifying images of dogs and cats, we would not just ask one individual model for its decision, for its classification. We would ask multiple different models, and then we would average their decisions, for example, to reach a less biased and less error-prone decision. So the idea is we have individual models. These individual models can have or can make individual mistakes that are maybe quite unique to the model type or maybe quite unique to the hyperparameters. So they might overfit the data or make some other mistakes in a very unique way that all the other models maybe don't do. But those models, again, can have their own mistakes. And by averaging out their decisions, we hopefully reach a conclusion, a classification that is less biased and more correct. So when we evaluate it on the full test data set, we get a higher performance than when we ask all the individual models that are part of the ensemble. That's the basic idea. And today we're going to look at a specific implementation of that, which is the random forest classifier, the random forest classification. And the idea here is to take multiple individual decision trees that do the classification task and to then combine their decisions into a random forest. So multiple trees are combined into a forest, and this is the random forest classification that is based in multiple decision trees. So we're going to do this first of all from scratch. So we're going to train individual decision tree classifiers, and we're going to then average their decisions, and then we're going to look at the actual random forest classification from scikit-learn. At least when I prepared this video, I got the exact same results. So let's see if this is the case again, because there is some randomness involved here. But we're going to start here by importing, or actually by installing the packages scikit-learn, so scikit-learn and numpy. Those are the packages we're going to need today. NumPy just to work with arrays, and scikit-learn because this is the package for traditional machine learning algorithms and models. So we're going to start by saying import numpy as NP, and then we're going to say from sklearn.datasets, we're going to just use the breast cancer dataset, which is just a dataset containing some information about the sizes of tumors, and then it tells us if it's malignant or benign. It doesn't really matter what dataset you choose here. We're just going to use some dataset that is useful for classification tasks. So here we're going to import load breast cancer. Then from scikit-learn.model selection, we're going to import the train test split. From scikit-learn.tree, we're going to import a decision tree classifier. From sklearn.ensemble, this is what we're doing here. We're going to import the random forest classifier. Again, we're going to first create our own ensemble with decision tree classifiers, and then we're going to use the actual ensemble classifier here from scikit-learn to compare the performance. And then we're also going to say from sklearn.metrics, we want to import the accuracy score. So those are the imports, and now we're going to start by loading the data by saying load breast cancer, and then we're going to split it into X and Y, so into the actual data, into the actual features, and then into the target variable as well. So data.data and data.target. Now this XY data, we're now going to split it into train and test. So into training set, into a testing set, so that we can train the model on the training data and evaluate it on the testing data. So we're going to say X underscore train, X underscore test, Y underscore train, Y underscore test. And this is going to be equal to train test split X and Y, and the test size is going to be 0.2. So 20% of the data is going to be for testing. This is now just our data. What we're going to do now is we're going to say how many trees we want to have. So let's say we want to have 100 trees. What we're going to do is we're going to say for I in range, and then 100, because we want to have 100 trees. And above that, we're going to initialize an empty list. So we're going to call this the tree list, for example, which is just going to be empty. And we're going to now train decision tree classifiers on the data, and we're going to add these classifiers to the tree list. So tree equals decision tree classifier, and we're going to say max features are going to be equal to square root. So this is just a method for determining the max features. And then we're going to say now subset. This is important. I forgot to mention this. Of course, we're training the classifiers on subsets, on different subsets of the data, because we want the models to be as independent as possible. Now, this will not happen. They will not be completely independent, especially because they're all decision tree classifiers. But we want to have at least as much difference as we can have, as much independence as we can have. So we're going to use different subsets of data. And for this, we're going to say subset indices equal np random choice, and we're going to choose from np range length xtrain. So we just pick some random indices here. How many size equals integer, so truncating it, length of xtrain divided by 2. So we basically, actually I can also do a floor division here, right? Why did I do it like that? I don't know. I think this is better, like this. So we have the subset indices, and what we want to do now is we want to actually get the data. So actually from these indices get the actual rows here from the xtrain and ytrain. So we're going to say x underscore train underscore subset is going to be equal to xtrain xtrain. I'm still getting used to my new keyboard here. Subset indices, and then ytrain subset, ytrain subset indices. And then we want to fit a decision tree classifier onto this. So we want to say tree fit xtrain subset, ytrain subset. And then this tree shall be appended to the list that we just created above. So append this tree. And again, hopefully all of these are going to be somewhat independent. We want to have 100 trees that are all kind of different, and then we want to let them vote on the same issue. So we're going to say here now, predictions, preds is going to be an empty list. And then we're going to go through the test data now, and we're going to let each model vote, let each decision tree vote on the issue, whether this is malignant or benign, and then we're going to see how correct the ensemble is. So how correct all of these models together are when we average the decision. So for I tree in enumerate, and then we're going to enumerate, of course, the tree list. And then we're going to say the individual underscore predictions are going to be equal to tree dot predict x underscore test. So we predict on the test data what the y data is going to be, in the individual accuracy. So for this individual model, the accuracy is going to be calculated by accuracy score, y test, and the individual prediction. So we let this one tree that we're currently looking at, we let it predict on the data, and we evaluate its individual accuracy. So not of the ensemble, of the individual decision tree. And we want to then print here, just as a message so that we can keep track of this tree, and then we can say I plus 1 so that we start counting at 1. So tree I plus 1 is going to have an accuracy, or has an accuracy of, and then individual accuracy, so that we can see what the difference is between the individual trees and the ensemble. And by the way, this is not always going to be better. Not in all cases will you have better performance just because you use an ensemble, but oftentimes you will. So you can also use, by the way, from scikit-learn, the voting classifier to combine any models. I have a video on this, by the way, but not always will you outperform the individual classifiers, especially when you have some very powerful models like random forest classification in the ensemble, because of course you can have an ensemble inside of another ensemble. This is also possible. So yeah, so we have the tree accuracy here, and then we want to, of course, append the predictions that we made to the list. So individual preds, like this. Now, with these predictions from all the trees, we now want to average them. We want to get the mean prediction. We want to round it, of course, up or down. So we want to get the mean. Since we have here between 0 and 1, we will get something like 0.2, 0.8 or something. We want to round it to what it's closer to. So if it's 0.8, we want to have a 1. If it's 0.2, we want to have a 0. So what we do is we say predictions. We want to turn this into a NumPy array. So predictions is going to be NP array predictions. And then we want to say mean underscore predictions. Or actually, let's say mean predictions is going to be equal to np.mean. And then we want to say predictions axis is going to be equal to 0. And around this, we can now say np.round. Like this. So this takes the mean and then rounds the mean up or down, depending on what the value is. And then we get our predictions. And now we want to calculate the ensemble underscore accuracy, which is going to, of course, be just the accuracy score applied on these mean predictions and the test data. So let's do it the same way that we did it before, y-test and mean predictions. Maybe we should call this a different name. Maybe we can call this ensemble underscore predictions like this. I think we can run this now. This shouldn't take too long. And of course, we need to print the ensemble accuracy. But yeah, you can see a clear picture. I think in this case, it's very obvious. I mean, not exactly. I think you have a lucky tree here, for example. But if you look at most individual trees, they have an accuracy around 0.93, 92, 90, 89, stuff like that. We have this 32 tree here, which for some reason has 95.6%. But you can see that the ensemble in the end has, oh, it actually also has 96%. Okay, so it's actually quite good. What was 32 exactly? 9.5. Okay, so actually the ensemble outperformed every single tree in the ensemble. This is the accuracy when you combine all of these votes, but the individual votes, as you can see here, if you just look at one individual tree for every single classification, all of them perform worse than the whole ensemble. And now we can see if this is also, if we get the exact same accuracy with a random forest classification, we can say here random forest equals and then random forest classifier, train it, of course, on, or actually, first of all, we need to specify how many trees we want to have. To keep it consistent, we're going to go with 100 here. It's not n trees, it's n estimators. There you go. And then we're going to say rf.fit. We're going to fit it on the training data. This is automatically going to do everything behind the scenes that we did manually above. So xtrain, ytrain. And then we want to just say rf predictions. We don't want to use evaluate or score because we want to do it the same way that we did it up here with the accuracy score. So yprets. rfprets is going to be equal to rf.predict. And we're going to predict on the test data. And then we want to say print accuracy score of y-test and rfprets. And you can see in this case, actually, the random forest classifier outperformed our ensemble. Here they are the same. Here, our classifier outperformed the random forest classifier from scikit-learn. Here, they both have, again, the same accuracy. Yeah, here again, it seems like we're getting better and better. Yeah, but you can see if we look at a very good example here. Now, can we find a counterexample? Is any one of these trees? Yeah, this one has. This one here has a performance of 0.93, whereas our ensemble performs worse. But this is very rarely the case. I mean, here we also have an example, but you can see that most of these individual trees are worse at the task than our ensemble. And this will also be the case if you have more data. So the more data you have, the less lucky the individual tree can be. But yeah, you can see that most of the time we get pretty decent scores here, and the individual trees are not very powerful. when it comes to the predictions. So this is the power of ensemble learning, and a random forest classifier just means multiple decision trees working together. So that's it for today's video. I hope you enjoyed it and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. And of course, don't forget to subscribe to this channel and hit the notification bell to not miss a single future video for free. Other than that, thank you much for watching. See you in the next video, and bye.